Thank you for coming. This is Practical Container Scenarios in Azure. First and foremost, let's thank the sponsors for what they do for this community. Fantastic group of people. Come on, let's see what I did there. Hey, I'm Anthony Nocentino. I'm a principal field solution architect at Pure Storage. I make computer systems go really fast. That's my job. I've been a Microsoft MVP for the last couple of years. In about 2017, the SQL Server team showed me what this Kubernetes thing was, and I was like, hey, that's going to be a thing, and here we are. I've written a bunch of courses for Pluralsight on this exact topic. If you want access to that content for free, just please shoot me an email, and I will give you a trial code to get access to that. So we're going to go through a couple big buckets of information today. I've deleted many slides from this deck because I just want to get into the code because that's what really matters. But we're going to talk about what a container is. We're going to build a container image from an advanced cloud scale hello world application that I built myself. That we will then also look at how to work with Azure Container Registry and really what that brings to the party from a systems standpoint or CI/CD standpoint. Yes. Was anybody in April's session 2 sessions ago? Right. So this would be the precursor to that. And then you bolt on all the goodness that you saw in her session, and you're able to build automated build pipelines. And we'll talk about what that means from a code standpoint when we're done. Has anybody worked with a container before today? Cool. Has anybody worked with Azure Container Registry before today? Half of y'all. All right, and AKS. Anybody worked with AKS before today? All right, look at the net got smaller and smaller each time I asked that question. So, all right, we're going to start off with what a container is. And really, what a container brings to the party is the idea behind virtualizing the operating system and its resources. Very much so different than machine virtualization. And so that's how we're able to do things like basically pick up an application that we built on our desktop and put it on a server, and then put 10 copies of that on the server, and they don't interfere with each other. But inside a container, what it really is just our application that we're going to build. And that's what we're going to focus on today, is building some applications and also including the libraries with that. So a little bit of latency when I click, but that's a me problem. Generally speaking, we're going to put one application inside of a container. And again, we're going to build an application together today and do that. And the biggest thing to understand from a scalability standpoint is it's the unit of work. At the end of the session today, we're going to deploy our Hello World application into AKS, and then we're going to scale it to many numbers, or 50 replicas of our application. And I come from the world of virtual machines and servers and things like that in the early 2000s. And when I get to the end of the session and then being able to take an application and scale it to 50 independent copies of an application across multiple nodes in an AKS cluster just blows my mind, right? Because in the days when I had to go and build web servers and things like that, these are tasks that took hours, right? And so we're going to spend a bunch of time looking at how that works. And so when we're working with containers, we have a couple of things that we're going to talk about. The container image is the thing that we're going to build. Right, that's our application. It's the code. It's going to be compiled. It's going to have some configuration, usually injected by environment variables. We have a container registry. That's where those images live. We're going to focus on ACR today, or Azure Container Registry, but certainly Docker Hub has been the longest player in the game. But you can also run a container registry internal. There's some value to that from a security standpoint, and also a performance standpoint, because if my cluster is physically adjacent to the container registry, what does that mean? They can exchange information faster, right, for pulls and pushes. And a Dockerfile defines what we're going to put inside of our container image. And so what we're going to do is we're going to walk through one of those here in a second. And so the flow looks like this. If I want to create a container image, I write a Dockerfile, which is a series of steps to execute inside the container. Right, so build my application, copy the application in there, inject some configuration, right? Then when we run a build, that's going to take that stuff, execute those steps, and make a binary image of our application. That's the container image. Now that works on my laptop. We're going to do that here in a few minutes, but we're going to push that because I want to be able to exchange that information with you, right? Who's pulled a container image before today? Someone else pushed it into your container registry before you got the opportunity to pull it. And so working a lot with pre-built images like the PowerShell images or the SQL Server images, all this stuff is done by Microsoft for you or the container publisher, right? And most of the time, for me, I'm a consumer of what's coming out of a container registry, and that process is pulling. So when you pull a container image down onto a resource, whether it's a physical or virtual machine, and then you can run that application or multiple copies of that application or multiple applications. And so when we want to define what a Dockerfile is, it's going to be some code that describes what we want to do. And so today we're going to look at a container image built from mcr.microsoft.com, the ASP.NET Runtime 7.0. I upgraded all these for this conference here this week. And so what that's going to do is pull that base image. And so we're going to build our work on top of that. So I don't have to go and create that image. Microsoft cultivates that for me and gives me the .NET runtimes for me to go and do the things that I need to do, which is stick my application in there and have it run. And so what I mean by sticking my application in there, literally I can take a compiled version of my application and park it into the container image, right? And then from there, I'm going to define what port my application listens on. Now, when we get into the demos, I'm going to introduce a concept, what's called a multi-stage build. In this case here, I've already compiled the application on my local workstation, and I'm going to stick it into the container image. But we're going to look at what's called a multi-stage build here in a second, and we're going to talk about why that's important when we're building applications. This entry point is the thing that's going to start when we run the container image, whether it's locally on my machine, local in your machine, or in AKS. It's going to launch the .NET program, inject that DLL in an appropriate way, and then run that web application, okay? Cool. To build a Docker image, so once you take all this text, I save it to a file. I type Docker build. I give it a -t parameter, which stands for tag. I'm going to tag that image named my web app image, and then the period there is the build context or in the local directory. Docker builds are complicated things because you're basically saying, this is how I build and run my app. So there's a huge surface area of commands and parameters and configurations that you can use to build a more complex application. And you get a whole lot of goodness and fun stuff when you're trying to inject parameters and how your application reads them. So I suggest checking out that link there. So if you think about the workflow I had on the bottom of the screen a second ago, we just built our image, and I want to exchange that with you now. Because right now I have a copy of my application on this laptop, but I want to exchange that with you so you can consume that. And that's where container registries come in. They store the container images, and they can be public or private. When I say public, meaning be able to pull a container image from it in an anonymous way. And that can be how you want to exchange your container images with your coworkers or your customers. But you might also want to secure that for some reason. Maybe you have a beta version that you want to release to a subset of customers, or you actually want to keep your application off of the wild internet from having people to access that. And they can be secured in a couple of ways. Obviously in transit, I want to have that encrypted. But more importantly, there's this thing called an image digest that is a SHA hash of the actual binary image. Because if you think about what you're doing when you run a container, you're literally taking someone else's binary, pulling it into your data center and running it right there, right? Does that sound like a good idea, right? We would never do that under normal conditions, but it's kind of like getting an Uber. I'm going to call a stranger off the internet to come pick me up, right? But I want to make sure that with the code that was pushed by the publisher of the image matches what I think it is, and that's what the SHA-5 hash does, right? The binaries that I download match what was pushed into the container registry by the person that built that image. And this really becomes the key component of a CI/CD pipeline, because this is how we exchange the application. So all the goodness that you saw in April session this morning, you can think about what I'm talking about from a manual process now is automating that. So if I'm a developer, when I commit code, I can kick off a process that does this all for me automatically, and we'll extend that in a second. Images are organized by tags, which we're going to experiment with in a second, usually to identify a version of an application, but really giving you some information about what is inside the image. Docker Hub is the big one, and we're going to work a bunch with Azure Container Registry today, which is going to be available at that URL there, and we're going to see that here in a few minutes. And so let's do some demos where we're going to go and create a container-based application, build it in ACR, and do some cool stuff. Now, I did literally just exchange my laptop. So if I have some demo fails, it's all good. I have recorded demos. What's up? So let's get started. The first thing that we're going to do is we're going to build a container image. So Docker build -f. This is slightly more complicated than I showed you in the previous example, because what I have here is I have my applications in different folders. I have a V1 and a V2 version of my application. So all I'm really doing here is just saying my Dockerfile exists in that directory. And I'm going to tag it web app image version 1. And so when I run this code, it's going to go and execute the steps in my Dockerfile. The Dockerfile looks like this. I talked about what's called a multi-stage build a second ago. If you notice, the from here is slightly different than we looked at in the presentation, in that it's the SDK now. All right, so I'm going to pull the SDK down for ASP.NET, and then I'm going to copy my code in there, where a second ago I copied in the binary, right? Then I'm going to go and build my application inside the container image. So that's what's happening here. So focus on the high-level steps, not necessarily the nitty-gritty of each line. Now, when I'm done, I'm going to take the thing that was built here on line 12, and I'm going to stick it into ASP.NET 7 runtime. So if you think about the flow there, I started with the SDK, I copied my code in there, I compiled it, and then I copied it into the final runtime image. Can anybody think of a reason why I would want to do that? So if I'm building an automated pipeline, right, I want to be able to have that flow exist without me having to touch it. I don't want to go and build it on my local workstation. I want the computer to go do that for me. The other reason why is I could certainly build it and run it inside the SDK image, but that's a lot bigger of an image. We want to keep our image narrower, very tiny. And so when we come out in the end of this, we'll have a very small container image in the dozens of megabytes, actually low hundreds of megabytes for this particular image. And so that's the idea there with a multi-stage build, is I don't have to have the developer tools on my workstation. I can push this all into a CI/CD pipeline, commit my code, build my code in the container image, pass it off into the runtime image, then we're going to push that image into a container registry automatically in a pipeline. Cool. So before we do any of that, though, I need to make sure my application actually works, right? And so that's what we're doing here, is I'm just running the container image. And like I told you, I like to deploy Hello World at cloud scale, right? So Hello World version 1.0. And this host name here is actually just the container image ID. Awesome. So let's stop that and push that into Azure Container Registry. So I have a couple steps here to set up an ACR. So creating a resource group, just showing my resource group to make sure that it's there. Let's check the plumbing to make sure I can talk to my Azure account, which it does not look like I can. Oh, I did not initialize the variable. That's on me. Cool. Show. Cool. So I can talk. So I've pre-created the resource group. I've pre-created the container registry because they can take a second. And so here's the code to create your Azure Container Registry. There are SKUs associated with the registry with regards to things like redundancy and placing them physically adjacent to where your clusters are. So one of the things I did a second ago is I built the image locally on my system, but I didn't push it into ACR. ACR is a thing called build tasks, which allows me to do something like this. I can say ACR build, give it an image name, tell it what container registry I want to push it to, which is populated in that variable right now. And then I just point it to the Dockerfile. And what it will do at this point in time is it'll take the source code from my local system, zip it up, send that into ACR just as the source. Then it's going to execute the build for me in Azure. So now I'm sending up a couple hundred 100 kilobytes of code, or megabytes of code, depending on the size of your application, and building it inside of ACR. And then when it's done, it's going to automatically push that into my container registry. Why did that not build? Registry argument. I did not populate ACR name. Cool. Let's go back down and run that. And so what we'll see here in the output here in a second is it's going to do what I thought it was doing while I was talking about it a second ago. You can see it gzip my code. It's going to take that, push that into. So now I moved 6 kilobytes rather than 200 megabytes, which is about the container image size, on my system. So again, if you're building a build pipeline, these are the tools that you're going to build to do just that. And so I don't have to exchange the full weight of the image into ACR. Dude, awkward silence while I let that build, right? Any questions or comments, team? Nope. All right. This went a lot faster when I did it this morning, by the way. So the second thing so now we see that finished. And so I'll go ahead and kick off the second build. And on this other screen here, I have our container registry up and running. So if I go and I look inside of repositories, we will see my web app image is here now, and V1 and V2 are there. One was just pushed now, and one was pushed yesterday when I tested all my code. So with that, I didn't have to push that full image into ACR, and I saved the weight of that. So let's go ahead and get back into what I'm going to do next. So when we're, yes?
You said you didn't push the full thing into ACR, so you just pushed the instructions instead. So when that built, it pulled it down from wherever it came from?
So one more time, Jess, please.
You didn't have to push 200 meg in because you just said like the instructions, right?
Yes.
So where will that container come from when you do it?
Understood. Okay. So the question is, how did the container get into the registry, right? Yeah. So what's happening here is I told ACR to build the stuff in that Dockerfile, okay, which exists in this file system path here, right? And so if we go and look at the code here, the output, what it's doing is, I'm going to go back. It takes the source code from that directory, zips that source code up and sends it into Azure. And then once it's there, it pops it open, reads the Docker file, and then executes the Docker run command or Docker build command based off of that. And so you see all the normal stuff you would see from Docker build, but this is happening on an instance inside of ACR, not locally. And then, so you can see like .NET Restore, restored my web app, and it does all the stuff that we'd expect it to do as it's building. And then the very last thing that we see is it pushes it into my container registry. So now this container image is pushed into my container registry. And so the exchange wasn't, so Docker image ls 212 megabytes. The exchange was just the source code and the Docker file. So significant savings in space and time. But the real one is when you do this in like Azure DevOps or GitHub Actions, you're going to do it this way. Cool. Good question. Thank you. So let's get into a Kubernetes. What's a Kubernetes? So what we don't want to do when we're building applications is run around our data center and type Docker run on a bunch of servers, right? That's not a great way to build an enterprise grade application. And so really these are the things that Kubernetes brings to the party. It figures out where in a given collection of compute resources to run that application. That's all a Kubernetes cluster is a bunch of compute resources for you to push an application into. But then scale it too. I have a bunch of stories when I worked as a consultant in the e-commerce field where we'd have surges in traffic due to marketing or holidays and things like that were challenging to respond to because, well, I had to go crank out 50 VMs to be able to respond to that, not crank out 50 copies of an application. And how do you do that consistently? How many of us used to have build checklists back in the day, right? Those are things that you come back a week after you built the server and go, wow, who built this thing? Oh, that was me, right? And then how do you do that consistently? We're going to do that in code today. And how do I access the application? And that's what containers do. Container orchestrators, they figure out, given a collection of compute resources, where to run your application. Also managing state, right? If something goes bump in the night, you don't want to have to get paged anymore. You want your system to fix that for you automatically, right? So starting up your application, but also keeping it up in the event of a failure inside that system. Back in the day when we had to do this before, we put a server into production. What did you have to do? You had to go open a ticket to the networking team, say, hey, can you add this IP address to the load balancer, right? We don't want to do that in this new world with containers. We just want to scale our application to consume the services. Persistent storage, I come from the database space, so that's a big deal for us, but we're working with stateless applications today. And a declarative model, just run this in an environment. Run my application, give me 50 copies of it. And that's what we're going to do now. We're going to jump over into the rest of our demos to do just that. I'm going to actually populate my variables because I don't want to mess that up. So AKS is Kubernetes, and it allows me to deploy an application in a managed service. But all AKS really is a wrapper around a bunch of VMs inside of Azure running Kubernetes. And I have a whole bunch of war stories about folks that don't realize that there's finite resources on a node and scaling an application. Like, for example, by default, you get 2 vCPUs and 7 gigs of RAM. I had a customer that deployed an application on a Windows container that took 3.5 gigs of RAM, and they couldn't figure out why they could only healthily run 3 copies of their application on a 3-node cluster. I'm like, well, you're out of memory, right? So I already went and created this cluster, but this is the code to do that. And if you notice here on line 79, there's this attach ACR parameter now, which basically does the service principal plumbing between your AKS cluster and your ACR so that they can exchange information in an authenticated way. You used to have to do a whole bunch of like JSON stuff back in the day to do that, and it was a pain in the butt. We can go ahead and see that we do have our cluster available to us in the Azure portal. So one of the things that we can do from here is we can see it's actually a VM, so standard DS2 v2. We can see that there's this concept of a node pool, which is a collection of nodes, the version of Kubernetes that we're working with. But you also have the ability to add additional nodes here, or add bigger nodes at this point in time, depending on your app. Yeah, the answer I gave to that customer, I'm like, listen, you just need to swipe your credit card and get more nodes, more bigger nodes. And they're like, we don't think that that's the solution. And I'm like, do you not understand how memory works? So, ew, no. All right. So what I'm doing here is I'm grabbing the authentication credentials for me to interact with my cluster. And that's what I tested a second ago is, there we go. So that now works. This is basically just giving me the cluster information, testing and plumbing from my laptop to this AKS cluster that I deployed in the cloud. I'm going to ask for the nodes. You can see that there are 3 nodes in this cluster. Why did I deploy 3? Because each node, the compute cost associated with the node, 3 is the default. You can scale 1 if you you can deploy with just 1 if you want to have a smaller cluster. But you do have to pay for that. So when we're working with an application, let's see, we have to define access to that. And what I want to be able to do is I want to expose my application to the internet, right? And I want to send users to that. And so with this code here, I'm defining what's called a service. And a service is basically an entry into the cluster to access an application. That's a fancy way of saying it's an IP address, right? We're going to listen on a particular port 80. And if you remember the expose port at the end of the Dockerfile, that's this port here. So that's where we're going to send traffic to. So users go here, the load balancer goes there, right? The selector is a way for the load balancer to define who is a member, which pods or which containers that are running in a cluster are a member of the service. And you can do some really cool things with deployments and blue-greens and things like that by manipulating that, but that's for another show. And the type is load balancer. So this will literally deploy an Azure load balancer behind the scenes when I run this code. And so let's go ahead and do that. The next thing that we're going to do is, cross our fingers, there we go. So web service is created. Is we're going to deploy our container-based application. So we have what's called a deployment. A deployment will run a fixed number of replicas of our application. And so if I go down here, we can see inside the spec, which is the technical implementation details of the deployment. I want to run 1 copy of my app just to start, right? The selector, much like the service, defines who is a member of this particular deployment. And that's going to be great for when we want to update our application. We'll see that here in a minute. And then inside, this is called the pod template spec because it's inside the deployment spec. We see template, and then below that, spec. Here's the image that we just built. So this was the name of our Azure Container Registry. And this is the image that we pushed, and there's the container port. And so when I run this code here, what that's going to do is it's going to create our deployment. And it's already up and running. So the web app deployment, it went and pulled our container image, started it on one of the nodes in the cluster, and it's up, running, and ready. if a deployment creates a concept called a replica set, and then a replica set creates the pod. When you create a deployment, the idea is I want to cultivate the deployment over time. And the deployment defines the state now of what I want. And then it creates the replica set, which then creates the pods. When I change the state of the application, aka maybe change a configuration or I change a version, it'll create a second replica set and then create additional pods. And it'll shut down or scale down the previous replica set, right? So the idea there is I can roll out an application from V1 to V2 with potentially zero downtime, because the load balancer is going to be distributing the traffic to the pods. And then I can move from V1 to V2 declaratively in code. What's up, Joe?
Is the default to create and then destroy, or do you have to specify that?
The default, the question is the default to create and then destroy. There's two update strategies. One's called rolling update, and one is called recreate. Rolling update will slowly shut down, and there's some calculus you can do, some tunable parameters on the number you shut down and start up, because you don't want to run out of resources. And then you also don't want to impact the latency or the response time of your application. The other one is recreate, which literally shuts them all down and starts them all up. All right. You'll start getting to the point, like once your developers realize they have this capability, or you are a developer, then you start engineering towards that, right? You start building infrastructure and data structures in your apps to facilitate that transition with zero downtime. So let's access our application. I've tried so hard in my life to avoid JSON, but here we are, right? Kubernetes speaks JSON under the hood. We interact with Kubernetes mostly via YAML and kubectl. There's a whole universe of tools out there. I try to keep things to the vanilla, what's available to you by default, but there's a whole slew of tools to make this easier for you. If you were in the first session this morning, there were some pretty cool tools that were being used then. So what we're doing here is I'm just getting the IP address of the service. I jumped past this line of code here. Let me run that. So I told you I deployed a load balancer. So there's the load balancer, and it's got a real address. And this is just some JSON to cut up and give me this address in a variable so that I can test my application. So I am accessing over the internet our application that we deployed in AKS, right? So the app we deployed, V1. So that is literally running in some Azure data center somewhere in central US. Okay, cool. So let's say my marketing department says, you know what, you should really, everyone, try out this Hello World application that Anthony wrote. And there's like, go viral on Twitter, and I need to have more copies of my application running. And so what I can do here is I can just say kubectl scale deployment minus replicas equals 10. And so if I come back now, I now have 10 independent copies of my application running, and a load balancer is now distributing that workload. But think about what this really means to a business, right? And especially in a cloud, because I can just go and add more nodes, physical capacity. I can then add more copies of my application. And so I can respond to things like that in a way that allows my business to react and not lose sales, right? Because how many of us have gone to a website, click checkout, and it just grinds and spins, right? What do? You go somewhere else to buy that thing, right? And so you now have this capability for your business to be able to do things like this, right? Now I can go ahead and scale that to 50 if I want to get even spicier. And so that's going to run 50 copies of my application on all of this. And the other thing that is really neat is, since my container image is already on there, the startup latency for my application is very fast, because the container image is now resident on the nodes in the cluster. So it's just popping new containers without having to go pull that image down again. And so without having to open the ticket and talk to my infrastructure team, I now have load balancing across, no offense, infrastructure teams, if there's anybody out there, but you know what I'm saying. I made green lights blink for a long time in data centers too. So we can see by the different response and host name here that I'm being distributed to different pods in the cluster. Okay, cool. All right. So we walked through this deployment a second ago. You saw this code here. Now we pushed a V2 of our application. Same code, but this time I'm going to update this deployment declaratively, whereas the last two changes I made from 10 to 50 were imperatively. I think that's the first time I didn't screw that up, mixing up declarative and imperative. So if I go down to the container spec here, the only thing I change is the tag, because I have that updated application already pushed into my container registry. And the way that I roll that out is like this. kubectl apply -f v2. And so what it's going to do, it's going to start shutting down some pods. Here we can watch the status of that rollout with this code here. So kubectl rollout. So you can see it's rolling out the new copies of my app, and then it's going to wrap up by finishing and scaling down the old copies. What percentage of that? There's some defaults, 25% shutdown, 25% startup, and then when it cleans up the remaining 25%. But that's a tunable parameter based off of what you need. And so if I do this again now, you can see I'm on V2, right? It's pretty cool there. So imagine being able to do that from a coding standpoint, being able to roll out code like that in an automated way. And again, doing this as part of a build pipeline, because what will happen, once your developers commit code, you can kick off a build task, push your image into the registry, then generate the YAML associated with that, and just boom, roll that out into production automatically, right? It's awesome. So that is that. So let's do this though. kubectl get deployment. So we see our deployment is 50 out of 50. kubectl, Joe, this is for you, man. Replica sets. So there we have the current replica set ending in 7.5 with 50 desired copies, and the previous replica set ending in 6D28. Anyone want to guess why the other one's there and still scaled down? Bang. So if I messed up and I want to roll back, I can undo it with the kubectl rollback, right? Very cool stuff there. So this code will be available to you in the conference GitHub repository, but I'm going to call that a wrap. I skipped over a bunch of theory and went straight into the demos where we went and did all of these cool things. And what I want to focus on is things like, what do you do next from here? Like, obviously there needs to be some sort of data tier interacting with whether it be a PaaS service or an IaaS service, or if running a stateful application inside of Kubernetes is your jam, let's talk. I've written a whole bunch of content around that. But really, how do you want to make this production ready? Because hello world at cloud scale isn't exactly the coolest thing on the planet, right? So, connection strings are a big thing. SSL termination, app gateway, ingress are topics that you're going to want to investigate with how to route traffic into a cluster. And then we talked a whole bunch about this, being able to automatically deploy in our clusters with various tools. I'll add GitHub Actions to that after I saw the session this afternoon, right? Tons of content around this I've developed over the years. Microsoft has some great walkthroughs if you haven't done this before. I've, again, written a whole bunch of content on this for CKA and the AKS paths for Pluralsight. Not a sales pitch, just hit me up and I'll give you free access to that content if you want to. And so 32 minutes, right? It's a whirlwind tour of container images and things like that. But hopefully you go and you can get started with this on your container-based application deployment journey, but I'll open it up for Q&A team. Good? Just ask a question so I feel good. No? Okay. Awkward moments. All right, well, thank you all.